We're going to start the proof of the derivative of x then just by doing a couple of little examples like x squared and x cubed, and then I'll go into the general x to the n. So let's look at y equals x squared. So we've got an x squared function like this. We put a point on there and that's x. So this here is y equals x squared. We put another point here, which is x plus delta x. So this across here is x plus delta x squared. We define this little change to be delta x, that's why that's x plus delta x. This little change here is going to be called delta y. So given that this bit here from here to here is y, this bit up here is actually y plus delta y equals. Okay, let's set up our proof. If y equals x squared, then y plus delta y equals x plus delta x squared, which is x squared plus 2x delta x plus delta x squared. Then we subtract y from both sides to get delta y. Delta y would equal 2x delta x plus delta x squared, because this y has been subtracted off and cancelled with that one. Okay, now we divide by delta x. Delta y by delta x is equal to 2x plus delta x, and then we take the limit as delta x tends to 0 of delta y by delta x, which in this case, if you imagine this getting smaller and smaller and smaller and smaller, nothing's going to happen to that. We just get 2x. So that proves that the derivative of x squared is 2x. What about the derivative of x cubed? Well, we start in the same way. We imagine our graph like this, and we say that if this is x here, then this will be y equals x cubed. And then we go along a little bit, delta x, and we have a little bit of change in x plus delta x, which means that this will be x plus delta x cubed. And what that's equal to is, given that this is dx and this is a little bit of y, the change in y, this thing at the top, x plus delta x cubed, is y, which is that height there, plus delta y, which is that height there. So this is y plus delta y. Okay, let's go. Y equals x cubed. Oops, I wrote x there. Y plus delta y. Y plus delta y equals x plus delta x cubed, which is x cubed plus 3x squared. See how I'm using binomial expansion here? I'm going to use binomial expansion in a big way when I do the general proof. Plus delta x cubed, but basically that's what I'm doing, binomial expansion. That's y plus delta y. So delta y, if we take the y off both sides, gives us 3x squared delta x plus 3x delta x squared plus delta x cubed, which means delta y by delta x is equal to 3x squared plus 3x delta x plus delta x squared. And now we take the limit as delta x tends to 0, and we find that all we get left is 3x squared, because this one's gone and this one's gone, because delta x is going to 0. So hopefully you can see how it works, and that if I did to the 4, I'd have to the 4, then I'd have to the 4, then I'd have 4x cubed delta x plus 6 x squared delta x squared plus 4x. I can't do binomial expansion in my head, but anyway, it would be 1, 4, 6, 4, 1 would be the coefficients, and the power on the x would decrease, the power on the delta x would increase. Then we'd reduce the power on the delta x by 1 when we divide through. That would only leave that first term, well, the very first term is going to have cancelled when we take the y off, so it will leave the second term in. That will be the only thing not to do with delta x, and then when we go to 0 we'll get the derivative. So let's do that in the general sense. Here we go. So we've got our graph, and we've got x, and we've got y equals x to the n. And then further up the graph, we've got x plus delta x. So over here, we've got x plus delta x all to the n. And this is y plus delta y. This bit across here is delta x, a bit of x, and this bit's delta y. So we start our proof. Y equals x to the n. Y plus delta y equals x plus delta x to the n. We expand using the binomial expansion. X to the n plus n choose 1, well that was n choose 0 there. N choose 0, x to the n choose 1, x to the n minus 1, delta x, plus n choose 2, x to the n minus 2, delta x squared, plus n choose 3, x to the n minus 3, so decreasing those powers on x and increasing the powers, and this would go all the way across to delta x to the n. So we subtract by y from both sides. N choose 0 is 1, so this is just x to the n. So when I subtract y from both sides to get delta y, I just lose that first term. So I get n choose 1, x to the n minus 1 delta x, plus n choose 2, x to the n minus 2 delta x squared, plus n choose 3, x to the n minus 3 delta x cubed, plus blah blah blah, all the way up to that final term delta x to the n. Let's divide through by delta x. We get n choose 1, x to the n minus 1, plus n choose 2, x to the n minus 2 delta x, plus n choose 3, x to the n minus 3 delta x squared, plus all the way down to x delta x to the n minus 1. All the powers have gone down by 1. Now we take the limit of delta x tending to 0 of delta y by delta x, and obviously all of these terms have got delta x's in, so they're just going to go to 0, and that will leave us with n choose 1, x to the n minus 1, and n choose 1 is n. Yay! Feels good to actually know why that's true, yeah? Rather than just pulling a number down and taking one off.